In this video, we are going to look at another example under material balance of iron. So let's get into the question. With this question, they say an iron blast furnace produces 1,000 kilogram of pig iron of composition, 89% of iron, 5.6% of carbon, 3.6% of silicon, and 1.8% of what? Manganese. The charge in the blast furnace consists of the materials in the table below. Limestone is pure calcium carbonate and is converted to calcium oxide, which makes up 45% of what? The slag. So in this case, the limestone, which is the flux, some is converted into calcium oxide, which makes up 45%. So the limestone, which is the calcium carbonate, is then converted into calcium oxide, which makes up 45% of the slag. This means that when you calculate the total percent of the slag will be 55%, and 45% of the slag will be the calcium oxide. Let's see what we do. Now, they gave us a material reduced using 1,500 kilogram of coke. The analysis of the exit gas is giving us 26% of calcium, carbon monoxide, 13% of carbon dioxide, and 61% of nitrogen gas, assuming there is no loss of iron in the slag. So this is table, and this table is prepared by having a material. Sometimes the table will not be prepared for you. You need to do it. So we have the materials, in which we have the hematite there, and the rest forms the the slag. So we have the silicate, we have the alumina, and the manganese oxide. So in this case, we have iron or coke. Then you look into the question given to you. The percentage was given to us here. So this, they did not give it to us in the question, but they've done the table for calculate the amount of ore to calculate the amount of flux in that, and 3, the composition and the total slag. So for you to analyze this, I want you to put this down data. You can take a picture of it and you go by me or something like that. Yeah. So then we are moving on. Now, before you can do this, you need to have a block flow sheet diagram of what they are talking about. So this is the blast furnace. We have the blast furnace here, BF. And then we have 3 things coming in. We have the ore, which is the ore. We have the limestone. Let's see, we have the coke, and we have what? The limestone coming in. In this case, the limestone is the flux limestone. And then outside here, we have the flue gases, which was given to us, flue gases. The flue gas, and that one we have 26% of carbon monoxide, 13% of carbon dioxide, and 61% of nitrogen gas. You need to indicate this. Then we have the slag. In this case, we don't have the total composition of the slag. We don't have the total composition of the slag. And then we have the pig iron. From the question, they told us that the pig iron is what? Loaded as what? 1,000 kilogram. That's 1 ton. Please note that 1 ton is the same as 1,000 kilograms. So in a question that they don't use the kilogram, but they use the 1,000. They don't use the kilogram, but they use the ton. You know that 1 ton per ton means that the pig iron is what? 1,000 kilograms. So we have pig iron, and then we have a 1,000 kilogram. And then with the pig iron, from the question, you could see that we have some element in the pig iron. We have 89% of iron, 56% of 5.6% of carbon. We have 3.6% of silicon and 1.8% of manganese. So you need to put down that. It's very necessary because it helps you to solve the question. So we have 89% of iron. We have 5.6% of carbon, 3.6% of silicon and 1.8% of manganese. So in that case, when you get this, now the coke, they gave us that the coke is what? Loaded at 1,500 kilogram. Right? So we have this. This is the flow sheet. That's material balance. Mass in is equal to mass out. So the first question is asking us to find the amount of ore. Now, for us to find the amount of ore, we have two ways of finding them, and I'm going to show you. We can use A. So we are finding the amount of ore. Amount of ore. We have two ways of solving this. You can use the hematite, which is the ore balance, or you can use the element itself, which is the what? The ion balance. So I'm going to teach you the hematite balance. No, so for the hematite balance, we could see from the statement that we have hematite as an ore, and we have hematite, which is in the what? The pig ion. Why do I say it? Because we have some ion in the pig ion. Therefore, for material balance, we know that the ore itself, this is the ore. We have the ore here. When it comes here, we have some ion here. So wherever you see the ion, we need to balance it. So we know that for the balance, we know that hematite ore will be equal to the hematite in the what? The pig ion. Then we could find the amount of ore. So therefore, we go inside that. Now, when you come here, we could know that from the question, we know that the hematite in the ore was 81%, which is this. Hematite in the ore was 81%. So that means that we're going to get 81 over 100. Then times, we are using X to represent the amount of ore, which is X, is equal to, now with the hematite in the pig ion, we don't have hematite in the pig ion, but we have ion in the pig ion. And it's going to help us find the what? Hematite, right? Now in this case, we have a formula that you should know. For you to find this, we want to find ion in what? We want to find the hematite using the ion percentage. In this case, what you need to do that the formula is that you find the molar mass of the unknown mass all over the molar mass of the known mass times the percentage of the known, then times the mass of the pig ion, which is therefore 1,000 kilogram. I hope you understood this. Let's do the simplification for you to understand that. For us to simplify this, we know that this will be 81 over 100 times X is equal to the mass, the molar mass of unknown is what? The hematite ion, because we don't know this, we don't know the percentage, so we have the molar mass. The molar mass is just adding their molecular masses, and when you add them, we're going to get 160 over the molar mass of known, which is the ion. Ion is what? It's the case is ion, so it is 112. Here we have two more molecules of ion, then we multiply it by the percentage of the known. It's 89%, so 89 over 100, then times the mass of the pig ion, which is what? 1,000. So and therefore, when you do it correctly, you're going to get X to be 1,569.67 kilogram. As very simple as that. That's how we find the amount of ore in it using the ore balance, right? We could also do it in this way. We could also do it in the ion balance. That's what I told you. For the ion balance, we are going to have the ion in the ore is equal to what? The ion in the pig ion. So in this case, when you are doing that, we know that the ion in the ore, we don't have ion in the ore, but we have hematite, right? So what you do is that the molecular mass of the unknown, which is the molecular mass of the unknown, is what? The ion, which is 112, all over the molecular mass of the known, which is 160, times the percentage of the known, which is 81 over 100, then times X, which represent the ore, is equal to 89 over 100. In this case, you have ion in the what? The pig ion, which is 89 in there. This one. Then times the mass of the pig ion, which is 1,000. In this case, when you do it very correctly, you're going to get that X is equal to 1569.67 kilogram. The same value. Now let's move on to number 2. In question for B, they are asking us to find what? The amount of flux needed. And for the amount of flux needed, what we were said is that when you take, for B, when you take the flux, which is calcium carbonate, it's converted into what? Calcium oxide, which represents 45% of what? The slag. You get it? So you have 45% of the slag. So that means that what you do now is that you are going to find the total slag. In this case, for you to find the total slag, that means that the total slag will be what? 55%. Because the calcium oxide has taken 45%. So when you find the total slag will give you the 55%. Then if 55% will give you the total slag, what is 45%? And then you get the mass of what? The calcium oxide. Then you can get the mass of the calcium carbonate, which is a slag, the flux from that. Let me solve that. So for B, for you to find B, you need to find C first. For you to find C, you need to find the slag. So C, let's find C first. What is the slag? So we need to find the composition of the slag and the total slag. For the composition, we know that we have the silicate is a slag. We have the alumina is also a slag. We have the manganese oxide is also a slag. For you to identify the slag, they are always combined with oxygen, except the hematite, please. So with the slag, we have silicate, we have alumina, we have magnesium oxide, manganese oxide. So let's do the silicate balance. So for the silicate balance, let's go SiO2 balance. We need to know, go inside that. From our question, let's go to our question. Now, for here, we know that we have, for the ore, we have silicate in the ore, we have silicate in the coke. And also we have, when you check into the pig iron, we have a little silicon. So that means that, and we also have a silicate in the slag. So in that case, for you to balance it, we're going to get that we have SiO2 in the ore plus silicate in the coke, and then to the other side we have some silicate in the slag. That's what you are looking for. Then plus silicate in the pig iron, because we have silicon. As far as we have silicon, that means that we can use the molar mass of unknown over known to find the silicate in the pig iron. So in that case, we are going to just put in the values. For silicate in the slag, they say that silicate in the ore was 11%. So we are going to get 11 over 100, then times the mass of the ore was given as what? 1569.67. Then plus the silicate in the coke was 17%. So 17 over 100 times the mass of coke, which is 1500, which is equal to the silicate in the slag. So silicate in the slag, which we don't know, plus the silicate in the pig iron. We don't have silicate in the pig iron, but we have silicon. So what I told you, we're going to find the molar mass of the unknown over the molar mass of known times the mass of the pig iron. So then we know that the molar mass of unknown, so molar mass of unknown, which is silicate, is 60 over molar mass of known, which is the silicon, is 28. Then times the percentage of the silicon was 3.6. So 3.6% over, that's 3.6 over 100. Then times the mass of the pig iron was what? 1000. So in that case, when you do correctly, you are finding the slag. You are going to get that the slag, silicate in the slag, is going to give you 350.52 kilogram. Very simple as that. So that's the silicate balance. Let's go to the alumina balance. For the alumina balance. For the alumina balance, we know that we have, let's go to the table. When you check the alumina table, we have that we have alumina in the ore. And apart from the alumina in the ore, do you have alumina again? So we have alumina in the ore. So the alumina in the ore is going to alumina in the slag, right? So that's very simple. So then when you check, you don't have any aluminum here, which we can do anything to do. So for the balance of the alumina, we are going to just have that alumina in the ore is equal to the alumina in the slag. So alumina in the ore is equal to the alumina in the slag. So let's find the alumina in the ore. In the alumina in the ore was 6%, so 6 over 100 times the mass of ore 1569.67 is equal to the alumina in the ore slag. Therefore, the alumina in the slag becomes what? Alumina in the slag becomes 94.2 kilo. Now left the last one that we're going to deal with, which is the the balance for the slag manganese oxide. So for manganese oxide, we know that, let's go to the table. We always use a table, it's very important. Now from the table, we know that we have manganese in the ore, and also we have manganese in the pig iron. As you can see, you have 1.8% of manganese, and then we have manganese in the slag. So in that balance, you're going to get manganese oxide in the ore is equal to, but we don't have one in the coke or the flux, is equal to the manganese oxide in the pig iron and plus manganese oxide in the slag. So you are finding the manganese oxide in the slag. So the ore, we know that the manganese was 2%, so 2 over 100 times the mass of the ore, which is 1569.67, is equal to the manganese in the pig iron. We don't have manganese oxide in the pig iron, but we have manganese. So in that case, you're going to use that formula: mass of molar mass of unknown over molar mass of known times the percentage of the known. Then if you have times the mass of the pig iron. So in that case, the molar mass of unknown of manganese oxide is 71 over the molar mass of known, which is manganese, it's 55. Then times the percentage of the manganese in the pig iron is 1.8 over 100. Then times the mass of the pig iron, which was 1000. Then plus the manganese oxide in the slag. So and therefore, when you do that correctly, we are finding the slag. When you do the chain of substitution, you're going to get that manganese oxide in the slag is equal to 8.15 kilogram. So for the total composition, we have 3 composition, which is the manganese oxide, have the silicate and the alumina. Now for us to find the total slag, we're going to just add the slag that we have. So we have the manganese oxide, which is this, plus the alumina, which is 94.2, then plus the silicate, which is 350.52 kilogram. So therefore, the total will give you what? 452.87 kilogram. This is due to my approximation. Now let's go to, after getting this, so we are done with our C. Now let's go to the B. We find the amount of slag. As we've said in the first, when we started at 45%. So the slag is calcium carbonate, which is therefore converted to calcium oxide, and it represents 45% of the slag. So therefore, when you find the total slag, that will be 55%. So then, if 55% that we found, if 55% is equal to what we had, 452.87 kilogram. This is due by approximation. Let me see. Let's see what we had here. Yeah, 45. Let me see. We want to see the total. Yeah, 452.87. So what it means that 45% of the slag is calcium oxide, right? So therefore, the total slag that we found represent 55% of the slag, which will give you 452.87 kilogram. Therefore, what will be 45%? So ratio proportion, that will be 45 over 55 times 452.87 kilogram. In that case, the calcium oxide mass will be, is going to give you 370.53 kilogram, which is the calcium oxide, which represent the 45% of the slag. And therefore, the slag, the flux we are finding here is calcium carbonate, but we have what? Calcium oxide. So for the calcium oxide, for us to find the calcium carbonate, you are going to use the mass of unknown over mass of known times the composition of the known and the percentage of the known in the mass. So and therefore, let's come here. So we have that the 45%, the slag, which is the calcium oxide, which was the calcium carbonate converted to the calcium oxide. We'll do it like this. So therefore, For us to find the flux needed, which is a calcium carbonate, what to do now is that we are going to do mass of unknown over mass of known times the mass of what? Known. So we have the mass, but this one we are not using percentage, we are using the mass. So mass of known. So let's do that. So that case, when you are doing that, we know that the molar mass of unknown, which is calcium carbonate, is what? 100. And the molar mass of known is what? The calcium oxide, which is what? 56. Then times the mass, which is going to give you 370.53 kilograms. So therefore, when you solve it correctly, you're going to have that the mass or the flux needed is going to give you 1.66 kilograms, which is the flux needed. So we have similar type of questions that they will give you the when calcium carbonate is converted to calcium oxide, it forms some percentage of the slag. This is how you do it. So first you find the amount of ore, then you find the each slags and their composition. You find the total composition of the slag, and note that the percentage given to you, which was 45%, which represent the calcium oxide of the slag, that means that for the total slag that you find using the rest, is going to represent this percentage minus taking it from what? The 100%. I guess that's why we had 55%. Then you do ratio and proportion. If 55% will give you the total slag, what will be 45%? And then you solve it and you get the calcium oxide. After getting the calcium oxide, we need the flux, which is the calcium carbonate, the mass of it. So you do mass of unknown over mass of known times the mass of known. This is molar mass, MR is molar mass, and then mass of known. Then you get the what? The amount of flux needed. Thank you very much for watching this video.